Okay, so to continue the quarter 2 progress check review, number 28 says, state the characteristics for cosine inverse. Well, in case you forget what cosine inverse looks like, we can plot the cosine graph. It goes from 1 to -1, and then the inverse is reflected over the line y equals x, so these y values become the x values, and the x's become the y's. But I'm just going to turn it to the side for a second. This is not a function if we graph all of it. So the only parts that we graph is one part of the wave. We take from here to here, this part for the inverse to be a function. So the domain, this is cosine inverse, is -1 to 1. The range is 0 to pi. And this graph is decreasing. And I know it's not specifically in the packet, but if we wanted to do sine inverse, that graph goes from pi over 2 to -pi over 2 on the y-axis. Because if you think of our original function, if you start at 0 and go to pi, now that's not going to be a function if it's an inverse. But if I go backwards a little and I take this part, now my inverse is a function. So at pi over 2, we're at +1. Oops, up here. And at -1, we're at -pi over 2 down here. So the domain is -1 to 1. The range is -pi over 2 to pi over 2. And this graph is increasing, not decreasing. For 29, evaluate the expression or write undefined. You can use the unit circle to help. I'll use this to do my quadrants that are positive and put my quadrantal angles on here. But I like to draw the special right triangles. It doesn't say whether here's radians. So I'll draw it in radians and I'll answer in radians. So pi over 6 and pi over 3 give me the 1, 2, √3 triangle. And pi over 4 gives me 1, 1, √2. Okay, so tangent inverse of 1 is asking me what angle gives me a tangent ratio of 1. Well, let's put that 1 over 1. And I know tangent is opposite over adjacent. So I want to know what opposite over adjacent are the same, and that's here. So that gives me pi over 4. And for my inverses, cosine goes from 0 to pi. And tangent and sine inverse go from -pi over 2 to pi over 2. So pi over 4 is the positive quadrant for tangent. When does cosine ever equal 3? It won't. That does not exist. That's undefined because we know that cosine and sine go to max of 1 and -1, and 3 is way out of that. Sine inverse of -√3 over 2. So sine is opposite over hypotenuse, so I want to know what angle gives me an opposite of √3 and a hypotenuse of 2. Here's the √3, so opposite is pi over 3. But negative, so this is the tan inverse and sine inverse picture. So the negative quadrant is down here, so that's -pi over 3. You cannot give the answer all the way around. That's out of the domain. Nope, sorry, that's out of the range of answers for sine inverse. Hey, good thing I did this. Our answers can only go from negative pi over 2 to pi over 2. So I have to make this the negative pi over 3 for that answer. These problems have a double step, so now it's saying opposite over hypotenuse. What angle gives me the opposite of 1 and a hypotenuse of 2? But that's inside sine, so opposite of 1 is pi over 6. This is a positive fraction, so I can leave my reference angle as pi over 6. And then do sine of pi over 6, so sine is opposite of hypotenuse, the answer is 1/2. For this problem, we start on the inside and do sine of 7 pi over 6. But I'm going to leave my inverse here. So first, sine of pi over 6 is 1/2. But 7 over 6 is a little more than 1, because like this would be 6 pi over 6. So a little more than 1 puts me down in the third quadrant, so this is a negative 1/2. It's going to be similar to this answer. So sine of what angle gives me an opposite over hypotenuse of 1/2? Pi over 6. But negative with the inverse puts me down here, so negative pi over 6. Last but not least, which restriction of the domain of sine of x results in a function whose inverse is also a function? Oh, okay, back to this. Let me draw my normal sine function. Okay, 3 apply. So inverse is switched. If you don't want to think of it vertically like that, you can think of the horizontal line test to make the inverse a function. So 0 to pi is here. That is not true. 0 to pi over 2, that works. That's a function. Negative pi over 2 to pi over 2 is a function. 0 to 2 pi, definitely not. Pi over 2 to 3 pi over 2, this piece would be a function.